All right, well, good afternoon, everyone. Welcome back to another exciting day of mathematics. Whoop, whoop. Warm-up 106 is on the screen. You should be just about done with that. Hands if you need more time. All right. So today we're getting into the chapter on normal distribution. A lot of the work has already gone into that. Bless you. And we should be able to transfer what we got so far throughout the year to this. So it should go a lot faster than usual. So let's finish up. And I'll give you a code as soon as you're done so you can send me your warm-up. Let me get that up. Copy and go. All right. So we good? Yes? All right, check with the name, see what they got for the warm-up, please. All right. Whoa. All right, get us started, please. Get my curve going. All right, mean. What you get for the mean, Vince? 20 point what? 8.3. Hands if you got that. That's about right. We need a variance. Pass someone. Marco, variance. 145.8. Hands if you got something like that. All right. Standard deviation, pass someone. 13.197. 13.19. 197? Yeah. All right, so I'll round it to 13.2. Hands if you got something like that. All right, so and 13.2, that gives us 34.03, and over here it's at 7.63. Something like that is our normal range. All right. How about our z-score? Pass someone? And if we got that, something close, looks about right. So 0.35, I'm going to break this into threes. It's about right here. I want you to label that because we're going to come back. Today we're going to be using this a lot. So like I said, this would be a lot of the work already we've been doing on the warm-ups. And as you guys know me, I try to give you guys everything ahead of time, so here we go. So we're going to be using this. Keep that in mind, and we'll come back to that. Copy the agenda, please. Warm-up 106, normal distribution. We're moving on. And home plate for tonight, only 10 problems, only. But like I said, I think some of you will be able to finish here in class. Going to go super fast, so stay with me. All right, so like I said, 10 problems for home plate. And I'll show you that towards the end and get a Cornell note going. Our objective for today, I can define and compute the normal distribution. I can define and compute the normal distribution. Also, FYI, guys, we're getting closer and closer, I know, to the end of the year activities and such. However, we are going to be visiting IVC before the end of the month for our math competition. So just know I'm going to put together a couple teams from statistics to go. So when I call you, just let me know if you're available during those dates, because I know some of you are in sports and such, and we'll go from there. Okay? Okay. A math competition. We haven't had one, I think, in 4 years from IVC because of the COVID shutdown and all that great. They're barely bringing it back this year. How about them apples? Pretty good, right? All right, I can define and compute the normal distribution. So, where have we been? Well, we know our probability. We talked about variables. And then we were working with which kind? With discrete variables, because we focused on the binomial theorem, multinomial probability and such. However, now that we're moving on to normal distribution, discrete variables kept it finite. You only were focusing on 2 particular values or such, whereas continuous now is going to have us focus on all values between 2 values. And we're going to be talking about that in regards to applying it to probability in our normal distribution. So, really quick, look up to the screen. What are the distributions that we're going to be looking at? 3 of them. The first one is called symmetrical. Don't copy that, just pay attention. The second one is called skewed left or negative skewed. The third one is called skewed right, or also known as positive skewed. Look at the 3 of them. Talk it over to your neighbor. Let them know what's the difference from one to the other. So like that. And specifically, what makes left skewed and right skewed so different? Talk it over to your neighbor. What makes them so different? All right, so here goes. Your neighbor should have said, well, for the left skewed, the mean is to the left of all the other values, the median and the mode. The right skewed, the mean is to the right of the other values. And here, the symmetrical, they're all centered around the same spot. Okay? So, let's talk about symmetrical or normal distribution. Copy this, please. Copy this curve with the percentages. I'll give you some time, and we'll break it down by section. All right, so here's our normal bell curve. And in case you were asleep the entire year here in this class, you don't know what these components mean, but here it goes again. This is mu for mean at the center. That means that this one over here is 1 standard deviation from the mean, 2 standard deviations from the mean, 3 standard deviations from the mean on the positive end. Over here is 1 standard deviation from the mean, 2 standards, and 3 standard deviations from the mean on the negative side. Okay? So, look up to the screen. So if our normal distribution is here, look up, normal probability is right here, or average. Tell your neighbor the percentage for each of these. What's the percentage south or to the left of the mean, and what's the percentage to the right? All right. Let's see. Samuel, what's the percentage here and here? What is it? Yeah, 68 for both of them. But what is it here and here? Very good. 34.13. Label that, please. Tell your neighbor why. Bless you. All right. Next. we need this one and this one. Tell your neighbor how to find this and this. If from here to here is 95.44, what shall we do? All right, so what do we have in this section? Help us out, Jet. What'd you get? What is it? Very good, 13.59. And how do we get that, JC?
You take 95, subtract 68.
And divide by, all right. And last but not least, well, up to right now, we need this section down here and this section down here in the bell curve. So, tell your neighbor what you got for this section and this section. All right, good conversations. Let's see what you get for that section. Matthew, what'd you get? Boom, let's go, 2.14. And which leaves us the cream of the crop up here, and of course the other side or the other end. Tell your neighbor what that would be. All right, so with that said, look up to the screen. So if you notice, we have percentages under the curve. That is what is given for us in regards to probability. The probability of something happening is going to be falling under that curve. And according to what we know, this is the average range, which is this section right here. However, check this out. Look up to the screen. What was the z-score for the warm-up? Who had the z-score? Oh, I said I was going to divide it by 3, so it was somewhere around here. Can you give us that z-score, please, Andrew, again? 0.35. Well, that means something, guys. The z-score is a positional section of our bell curve. And what that tells us that whatever that number or that data was, let's say somebody scored whatever on a group of students on a test, and this person is positioned at this spot, well, they encompass a certain percent from all this section of the curve, all that section. Now, we know this part is what? 34. This part is what? This, and whatever is left over here. But what is it that we don't really can compute? This section yet, right? Until today. Today, we're going to be able to compute this section, including the little section of the z-score, to give us a approximate percent in regard to their position. Okay? And that is found by using a table. Oh, talking about z-scores, just to recap really quick, you guys have been using those on the warm-ups, yes? Everybody got those, yes? All right. Here goes the tables that we're going to be using. Can everybody see them? Pretty clear, yes? All right. Senator Gopher, I'm going to give you one for you and your neighbors. Come over, please. All right, so let's start with this. Look up to the screen. I just gave you a table. You have the table in front of you, yes? And we're going to be looking at the z-score that Andrew gave us. He said z-score of 0.35. And it's on the positive, right? Notice that it doesn't have a negative. So let's go to our table. Let me show you how to use that. I want you to start on the table to the right. and it says 0.0. Do you guys, everybody see that? We're right here. And I want you to go to 0.3, which is there. However, to make it 0.35, we need to look at the top over here for the 0.05, which is this one. So we got 0.3 and 0.5, 0.05. So where both of them meet, what do we got? Point what? 0.6368? Is that correct? So what does that mean? Well, that means, Mr. Q, look up to the screen, that whoever scores at that position on the Z is at 0.6 what, you said? 68? So what would be that in percentage? 63.7%. So that person is at the 63.7 percentile. I'm taking this from the Z-score on the warm-up. All right? Okay, let's try one, example one. Write this down. Z equals 2.06. Use your table, find 2.06, and give me a percent. All right, share with the neighbor, see what you got for that. What was the percentage? All right, percentage. Zach, what'd you get? 98%. Hands if you got 98. Looks about right. Let me just double check to make sure we got it. Oh. Let's see, what was it, 2 point what? 2.06? So here's 2.0 and 2.06. So that one is about right here, which is 0.98. Yeah, 98%. Do another one. Copy this one, example 2. Find the area to the left of Z negative 1.67. And shade that section to the left. All right, share with the neighbor the percentage, please. Percentage. All right, percentage. What'd you get for this one? Scarlett, what'd you get for percentage? What is it? 7.75? 4.75%. Hands, have you got that? All right, looks like it's correct. Let's double check. Negative 1.67, so negative 1.6 and 7. Yeah, 4.75. Yeah, percent. That is correct. All right, let's continue. How about to the right of 1.28? Find the area to the right of 1.28. Careful with this one. This one it says to the right of 1.28. One point 2.8. What was that? 1.28, and we want the right side. The right side. All right. So we need a percentage for the right side. All right. First, what do we do, by the way, to find the percentage for the right side? Talk it out with your neighbor. What do we do? Yeah, find the percent of the left side and then subtract from what? What is the total percent? 100, yes, that is correct. So who's got Z128? Let's see, 128, 128. That gives us what? 89.97, is that correct? All right. We got, this is 89.97. However, they want it to the right, not to the left. So what do I do? Subtract from 100, and what does that give us? 10.03%. Hands, if you got something like that. All right. How we doing? How we doing? From 1 to 5? Yeah. So going to the negative? Yeah. That's it. Bam. Just make sure that you don't use the a negative. All right. Copy this one, please. To the right of negative 2.23. All right. So now let me go back to the very beginning. Start with number 1. Look up to the screen. Now, this section, we're saying it's how much percent? 98%. Well, there's a way of explaining this as a probability. So, if all of this is Z, how would we show this in regards to probability using this number? What would I use? Talk it with your neighbor. How would I show that? Everything to the left of that Z. How would I show that? You got it? Yes? Let's see. Pedro's got it. Z is what? 2.06. But we're talking about the area as a probability. How would we write that? Z what? Oh, less than. Okay. Equal to. Okay. Hands if you got something like that. All right. Yeah, I'll take that. Write this down, please. The probability of the Z less than or equal to 2.06, which is all this area, can be expressed like that. If that's true, tell your neighbor how to express this one. How do we express that one? All right, JC, go. That is correct. How we doing? Good? All right. And of course we know how to do, well, this one. Yes? Good afternoon, Ms. Q. Will do. Bye-bye. Andres, you're going home. All right, so since we're done with the easy ones, here goes a challenge one. Find the area between 1.68 and negative 1.37. Talk it over your neighbor. Show the sketch first, so like that you guys can see the area. Write the percentage, and then write me the probability and notation. Copy and go. Let's see, walk us through your process. JC, what'd you get your percent for that area? 86.82%. Looks about right. And we're looking at the probability that anything that fell in there is in between negative 1.37 to 1.68. Okay, and what process did you do?
First, I broke it down, 1.68.
1.68, okay.
I thought like 0.9535.
95 what?
35. And then I found the Z for negative 1.37.
Uh-huh.
And then I subtracted the 2 to get 1.4.
So what was negative 1.37?
It was 0.0853.
0.0.
853.
Okay.
And then I subtracted the 2 to get a total of 86.82.
86, 82. Okay. So what you're saying is that in percentage, this was what? 8%? Okay. So from here to here, it's 8%. Is that what you're saying? Which means Wait a minute. So, oh, I see what you did. Okay, yeah, looks about right. All right, hands, if you got something like that. All right, so, with that said, take a picture of that. That's the home plate for tonight. You guys still have a little bit of time left. Shouldn't take you long. I'll stop the video right there. Enjoy. Bye.